And we are live.
Hi everyone.
Hello,
Yeah, we
everyone.
have
Hi, guys. We welcome
good
you.
morning, good afternoon, good evening.
Yeah. Yeah, we have to mention like good evening, good morning, and good afternoon. Why? Because we have different people from a different time zone.
Exactly.
It's night in Thiru's place, right?
Yep, it is
Yeah.
9:30 p.m.
Yeah. And it's like 12 p.m. at my location.
Yep.
GMAT is from Centennial. Sentinel? How do you pronounce it? So bad at pronouncing. Oh my god. Anyway, we'll be waiting for a couple of more minutes, and then I'll hand over the stage to Tiru to let you guys show the private data inference using LazAI computing API. So I'm very excited for this workshop because I'm going to learn more about data inference using LazAI. So show your excitement in the comment section. I would love to see your excitement in the comment section. And if you have any feedback, if you have any questions during the workshop, um, please feel free to drop your questions, comments, or feedback in comment section. Yep, we are waiting for your questions, and we are here to answer your questions, basically. Okay. I think we should start. So let me give you the introduction first. So my name is Nidhi Nakrani. I'm the devil from the Metis and educator at the Crypto Checks. Uh, we have Thiru, a devil from Metis, and he's going to take care of this live stream. And um, yeah, as you guys always see my face during, I mean, almost every Thursday on the same time. So today, Theo is going to take care of this private data inferencing using LazAI. So before I speak a lot, I will like to hand over this mic to Theo.
Awesome. Thank you so much for the introduction, Neri. So before we start, I would like to share some links in the comments for others to follow up. So I've shared the starter kit that we're gonna use for this session, and along with our AI inference docs. So this is really helpful for someone who wants to follow along. And I'm gonna share my screen.
I guess it's good to follow along so that if you have any questions while following us along, it would be good to ask at the same time, at the right time, and to get the really good benefit of us.
Course. And so to start with, this AI inference workshop is a continuation of the previous workshop that not the exact previous workshop, but like a couple of workshops ago. So we have the workshop of data contribution. So you can able to contribute your data. The data can be it still be a private data, and you will get rewards whenever LLM is using your data. So that is what we have seen in the previous workshop. So where the user contribute, and for their contribution, they can able to contribute to like Rust, Python, Node, and you also have a UI for it now. So you don't even have to execute code for that. You can just click buttons and contribute your data, and for that you will receive a DAT. So DAT is a data anchoring token. So this data anchoring token will be approved for your data contribution, and it will also use for tracking your data usage and wherever your data is being used, and you will get reward for that. So this is the crux that we have seen in the previous workshop. And so you have provided your data, but there's a use case that is what like to infer the data. So we are here with LazAI API. So how LazAI API changes this game. Here, you can able to infer the private data, and still you will have the privacy, and the data leakage is completely sealed. There's like no way this data is being exposed. So where this actually used, so we have seen in the previous workshop, like where the privacy is everything, like finance, healthcare, even like personalized agents, where it knows like each and every action that you do. So if like whenever this privacy is involved, we need something like LazAI to solve us whenever we want to infer on that. Let's say I want to like do a inference on my like all the income I have had, like all my financial statements, all my bank statements. So I don't want it to like I don't want to like put all my data into say ChatGPT or like a cloud, because my data is probably used to be trained, and then I don't want to like basically leak my data out in the public. So to avoid that, we can able to use LazAI, and we can able to do private data inference. So here we can start with the workflow. So workflow is basically consist of three main steps. One is you have to contribute your data to do the inference first. So that we have the contribution flow. You can check out the previous workshop as well. That workshop covered the end-to-end contribution flow. And once in the end of the data contribution flow, basically you provide your data, you sign a transaction, you will get a file ID, and the file ID is like the unique ID for your data is being on chain, and you will also get a DAT. DAT is a NFT, and you will also receive rewards whenever your data is being used by the LLM. And the second step is running an inference server. It is not for like it's not like the necessary step. It's not like everyone should have to run the inference server. So there's a like economic mechanisms that is different for inference server. So that is not what we're going to talk about in this workshop, but we will have in the upcoming workshop. So inference server is a server where the uh, the AI actually run. So you can able to run it on your local in your local machine itself, or you can do a remote inference. And this remote inference that you can able to achieve is through TEE. It can be Fala or any other services, and we're gonna use Fala TEE for this demo. And you can also do local inferencing as well. So this inference server actually process the request for the private data inferencing. And the final step is the actual inference, the actual request, the prompt that you send to read the data. And so uh, to clarify something, I'll be saying like a lot of inference, and then I've been saying this from the start of this workshop. Inference is basically uh, analyzing or like asking a question for giving a data. So that's what we do with any LLM that we use. We just give a PDF to ChatGPT and say like, uh, help me to understand this, or like summarize this paragraph. So similar to that, exactly that, but everything is like a private, and then there's like no your data is not being used, and there's like not like selling your data for the third party. So that's how like LazAI changes this game. So that's what inference is, and I'm gonna use the word inference even more in this workshop. So bear with me. How exactly you can able to request? So basically, you can use a LazAI client, and you can tap into an inference server, and you use a file ID, like which file you wanna like ask questions to. So that's all, and we will see each steps. We have again implementation in Python and Node live right now, and Rust will also be implemented. So soon enough, you will have implementation with any of these languages. Of course, with Python, we'll use. Uh, we're gonna see this demo in Python, of course, but I'll just give you a bit of a overview. I'm sorry, a bit of an overview in Node.js. So you install the dependencies, which is aleph. You have the tsconfig, So you basically need a node. So node is nothing but the inference server. So where you can able to request, and you get the address, you which file you wanna infer. So I'm gonna use the file ID 10, and this is the ID I've contributed. Which model you're gonna use, and you just give the request, and you will get the your response. And for this demo, we have a starter kit, which will have all the steps that you have to do. I also pasted this link in the comment section. And if you have any issues running with it, you can reach out to me. So you can clone this. I have already cloned it, and then it is running in my uh, terminal. But I also like started from the scratch for you. Okay, I'll start my terminal now. Is my terminal visible? Uh, can you see my terminal?
Yeah. Can you zoom enough?
Oh, cool. Sure, sure.
Zoom in, yeah.
Awesome. So I'll just go down to a folder and clone the starter kit. So this starter kit have Python. So as I showed you, you can also do Node.js, and Rust will be added in the docs soon. So this demo will be shown only in Python. I have installed, I have cloned the repo. I'm gonna just go through it and open it in Cursor. Sure. So I have also included all the required commands for it. So just start with creating a virtual environment, followed by activating the environment and install the alith dependency. Alith is the SDK that we are using to do the private inference. So the next step is you need an inference server. There's two way you can able to get it. One is running locally on your machine. Uh, so basically, running the inference server in the local host. That is what that's not what we're gonna do on this demo. And so what we're gonna do is we're gonna like use the inference server from a TE cloud, from Fala TE cloud that I have already deployed. And the next step is you need OpenAI or ChatGPT. So the OpenAI API key. The thing is, like, you can actually use the OpenAI API key itself, or you can able to use OpenAI compatible API key, which is basically free. So this one thing I've used for this demo is Open Router. So you can get a Open Router API key, and you can use it for this. Like the next step is have to export my private key. So I'm gonna stop sharing my screen, and I'll export my private key. Don't ever leak your private key to anyone. So not your keys, not your crypto folks. Yeah, quickly I will get the private key. Okay, I have exported my private key. So yeah, I'll sharing my screen again. So we are here. I have exported my private key. Now let's go to the inference.py. So this is where so we are basically importing aleth. and we have this LazAI IDAV address. So this is the registered inference server address. So this is the one that I've used for localhost. We need a different address, which is actually hosted in the Fala TEV. I'll get it. So that is like just one of my address. I'll pick it. Okay, I am forgetting my password. So this address that I've registered with the LazAI, how you can able to register your inference node. So for now, you can only register through admin, and there's currently only one LazAI IDAV admin. So you can free to use my address. I'll also updated it in the docs, so you don't have to replace with your own address. So you can just use it, and you can able to. Sorry, I just wanted to remove this comment. So you can use my IDAV address itself to request for the private inference. And we are creating an instance of client. And so this deposit is only required when you're inferring for the first time. So I've used it, so I don't need it. So I'm going to just comment it. And you can also like this is the try and expect accept section. So first, the client will check whether the user that who is currently trying to uh, do the private insurance is the existing user. So existing user is nothing but who actually already paid. So paid in a sense, you have to deposit uh, so that you can able to infer. So I've mentioned, right, you can get reward for contributing a data. Where that reward comes from? That reward is coming from the deposit inference. If I want to infer a data, I have to pay the deposit inference. So that's where the actual reward for the data contributor comes from. So basically, adding user and the deposit inference is basically the fee that you pay for the inference, but it's a one-time fee. It's not like you have to pay every time. So it's just a one-time fee. Thus, after that, you have to mention a file ID that you want to do the inference. For now, I've just selected the file ID 10 and followed with the URL to fetch. So what happens here is the get inference node function uh, will receive the IDAV address as a parameter, and it will return a list which have the URL in which the inference server is hosted. So the URL would be like if it is a local server, it will be the local host, and if it is a so currently we are using the Fala T cloud, so it will be the Fala's URL in which the inference node is being hosted. So we can see in the logs the how the URL looks like, and we have the agent instance. So here, this something essential with this. Otherwise, while integrating, you might hit the wall with few errors. So first thing is to mention the right model. So whatever the inference server have, we have to match it with it here. Otherwise, if let's say I've had a different model, let's say a GPT 3.5 turbo model that is running in the inference server, and I try to send a request using DeepSeek, so I'll definitely get an error. So we have to match it. So there's like only one inference server now. So that is have the DeepSeek R1 model. So use the same model. And if you're running your own model, so if you're running your own inference server with your own model, you just have to provide uh, the location of the file in your repository. So that will do. So yeah, and you can do the inference with your local folder itself. Like if you have a local model running, so you can also do that. So you don't have to use some like services like OpenAI or OpenRouter to get the API and then do the inference. You can do it with your local model as well. And we have the base URL. So base URL basically uh, the URL of the hosted inference node, and we will do a request, and we are sending the file ID in the headers, and oh, there's a typo. So we will send a prompt and we will get a response for it. Without further ado, we have already installed, right? So we can just run the inference script. Yeah, we are already in the virtual environment. Yeah, as I mentioned, it will first check for whether the user is already completed the deposit inference function. So it sees the get user function can able to return an address. So that's why we can see user already exists is printed. And following that, we can see the URL here. So something in the Fala.network, which is the inference node I have hosted. So if you host your own inference node, then uh, this wallet address, which we have used for the uh, adding or registering the inference node in the LazAI, that will return the respective Fala network URL that you have provided. And following that, you can see how it is processed, and we can see something. There is an issue with not found. So this like the API is not found. The actual issue here is I have registered my URL ending with the ending with a slash. So and for the base URL, I'm using another slash. So that is the issue. So that the agent unable to hit the API. So the endpoint is not found. When I remove it, uh, it will work. So the issue is you should register with the proper URL. Yeah. Now we have the summary from the uh, data that I have provided, and I will also show you a quick demo on how you can run your inference node on local. But the issue is here is only the LazAI admin and the LazAI IDAV admin who have the access to add an inference node. So we will have a interface for that sooner. So anyone can able to run a local inference, or anyone who wants to run a inference server, they will be able to do it. So I'll also give so running an inference server is actually really simple. I'll show how you can do that.
Are you sharing your screen like it's not
Yeah, yeah,
on
I'm
the
just taking
okay,
the yeah,
okay.
yep. I'm sharing my screen now. So far we don't have any questions. Is everyone so clear with AI
Yeah.
inference?
It seems, yeah.
It's cool, cool. Yep. And so this is how you can able to run your inference node in Fala. So I basically have the OpenAI API key. So I imported OS and .env. So this is both for getting the envs, and so basically Alit inference. I'm loading the env, just making sure the env is set, and the server, I'll just calling the run function and passing the open engine type OpenAI and the model. So here's the thing. The engine type OpenAI is used for if you are using OpenAI API key, or any model that supports that is like OpenAI compatible. There are like n number of models that are OpenAI compatible. You can find it in Hugging Face, Open Router, and many services, and a lot of them are free. Even the model that I'm using is free. And if you're using this kind of a free model, you have to include two extra environment variables, which is LLM API key and LLM base URL. Let's say I'm using Open Router. So Open Router itself will provide a base URL. I have to expose that, and along with the API key provided by the Open Router. If you are using any other external third parties, you have to use that other than OpenAI. If you are using OpenAI itself, you will provide the model of the OpenAI. So let's say GPT 3.5 or GPT-4, whatever the model that you are using, and you don't need to provide these variables. You will need only OpenAI API key and private key, of course. And so this is another dependency, the another environmental variable which will be required in order for you to run the inference node. It is a RSA private key, and if you want to deploy this inference server in Fala, you will need a DStack. So you can get DStack API key as well from their website. And this is actually uh, the starter kit for you to deploy your Fala cloud. I'll also put it in the GitHub and then share the repo link within the Alert starter kit itself. So any of you want to do it, you can basically do it. I'll have included the Docker file and everything. You just have to run like couple of commands, and then you will have your um, own Fala inference server. Still, you cannot start doing inference right away. So once you have deployed it, you have to request and get into the inference node. So you have to request whom? You have to request the admin of the LazAI. So LazAI IDA, and then through admin you can able to run an inference node. So this is how you can do it, and for this is for the production level. This is for you to like deploy it in the Fala cloud. If you want to just run it, just you just need a you don't even need these. You just need a alert inference, and just you can call the run function. Just two lines of the code. You can run your you can run your inference node in local. That's it. That's all it requires. So yeah, so that's all you can able to do with last year. You can able to do inference. You can able to do you can run the inference server. You can able to request and then get a response based on the file that you have shared. So these are like many cool things that can be built with it. And one of them that I can think of directly is I've even like used recently like for calculating my tax returns and how much I have to pay, and like giving like because like there'll be a number of transaction, especially with UPI in the play. So I needed some help with the AI to segregate my transactions, see how much I've wasted my money. So I can able to use for these purposes, as well as if I can think of any other use cases, that would be mainly for like personal something like for all my personal data. I've recently seen a tweet from a tweet, so where like they just provided their whole journal to a LLM and a local model, and then it will shows us like its past, its future, and it's like different versions like for each decision that they might take, and then how each decision will turn out to be, and it's like a different timeline. It's like a Marvel timeline. So uh, if any personal data and you want to like do inference on it, so last AI could definitely help you with that. So do you have like any other use cases that you can think of, Nidhi? I think you're on mute. You're still on mute, Nidhi.
Ah, now I see.
Yeah.
Yeah. So yeah, as you mentioned, the use case can be like where you have to, use encrypted computing API. You can like run the model and like without exposing the raw data, like even to your backend. So which use cases which really have, like, where you need this thing, and it keeps all the sensitive inputs like very privately and fully encrypted. So it can be used in healthcare bot as well, and in financial analysis tools, or in finance sector as well. It can also be used for a private copilot, like private, if you're creating your private AI agent, it can be very useful. Yeah.
Okay. Yeah. Thank you so much for like giving
Yep.
more ideas on that. Cool. I'm also like waiting for some questions on this. Yeah, I was expecting a lot of questions on it, but
Yeah.
yeah,
I
our
think you are
comment session is dry
thinking
today.
you are making things too easier. That's why they don't have any questions yet.
Yeah, I really wish that's true. Yeah,
It is true. Yeah, that's why they are like, they are understanding all the things that you are sharing.
awesome. Yeah, expecting a lot of projects integrating AI
Yeah,
inference with
yeah,
the.
exactly.
Yep.
If you guys like
Awesome.
integrate AI inference in your project, in your hyperhack project, please, please, please don't forget to share it with us. And like, you can use your X handle to share it, and please don't forget to tag us so that we can have the more visibility to your, yeah, integration.
And if you have issues while like the development, while the integration, you can also reach out to us.
Definitely. Definitely. Feel free to reach out to us on either on X or on Telegram group. And yeah, one of us will be solving your issues for sure. Yeah. All right. So if you don't have any questions, and if you don't see any comment or questions in the comment section, then I think time to wrap up.
Yeah,
What is it your,
yeah, it's time to wrap up.
yeah?
And just to give a final reminder for the community testing phase that's going to begin in 5 days from
Yeah.
July 15th. So that will be a fantastic opportunity for you,
Yeah.
especially projects building and hyperhack to get visibility, get initial users, get feedback, and get traction even before the completion of the hackathon. And you still have like more time to work and then iterate on your idea, iterate on your project, iterate on your UI UX. So utilize this opportunity. And if you have like any doubts on any process, like how do you get into this and how to start, we'll be active in forum, we'll be active in TG and X. You can reach out to any of us and we will be happy to guide you with it.
Yeah. All right, guys. So wrapping up, and thank you so much for being here. And if you have any questions, feel free to reach out to us on Telegram or on the Twitter. And yep, see you on the next Thursday with another workshop using a lead. So yeah, see you on the next Thursday. Till then, bye, guys. Take
See you.
care.
Bye bye.